Okay, this is a video on covalent bonding, section 9.4. Well, as you learned earlier when it came to ionic bonding, what happened was that the metal would lose its electron, ripped from it, stolen, taken away by the nonmetal. The metal would therefore lose its electron or electrons, causing it to become a cation. The nonmetal would gain electrons, causing it to become an anion, and the electrostatic attraction between the two would cause them to bond together or to be held together. And of course, if we are talking about representative elements, you recall the reason that they either lose or gain the electrons was to obtain a noble gas configuration, and that was the ionic bond. Well, we're dealing now with the covalent bond. You see, my friends, years ago, many years ago, scientists, chemists were aware of this thing called the molecule, but weren't exactly sure how molecules were held together until Lewis came up with the idea that the atoms in a molecule did not steal electrons one away from the other, but they actually shared electrons. And I'll put that in parentheses because it might be, one pair of electrons or two pairs of electrons, but they're sharing electrons. That's why I consider this to be the feel-good lesson of the year. I'm at school. This is the feel-good lesson of the year, the feel-good video of the year. You know why? Because it's all about sharing. Sharing. Just thinking about it makes you feel good, doesn't it? Sharing. Because sharing is caring. You all know that. Sharing is good. Sharing is fun. It's all about sharing. The sharing of electrons. The sharing of electrons to form a covalent bond. To form a covalent compound. A covalent bond. So, let's get right into it. Let's take a look at some examples. All right? So, since Lewis came up with this idea, hey, he said, I can use these Lewis dot diagrams, right? So remember, the Lewis dot diagram is showing the atom and its valence electrons. So there's fluorine, and then here's another fluorine, and we're going to show the atoms with their valence electrons. So what if these two come together and they share these electrons right there, right? Those electrons get shared, and we end up with something that looks like this. Well, the electrons that are being shared are sitting right in between it. And there are all the rest of the electrons. So these electrons right here, these are the electrons that are being shared. We call this a single covalent bond. Okay? So this is a single covalent bond. That's supposed to be an O right there. Come on. There we go. This is a single covalent bond. It's one pair of electrons being shared. One pair of electrons is being shared. One electron comes from one atom, one electron comes from the other atom, and they share the pair. We can also write the shared pair and replace it with a line instead of the two dots, because the two dots can be a pain in the neck. So we can also use a line there to represent the two electrons or the single pair that's being shared. So we've got a shared pair, a covalent bond. Now, why share electrons? Well, if we just look at this F on the left, how many valence electrons does it have? It has how many? Count them up. How many valence electrons on that side? How many, people? You can see that there's 8. And, well, let's erase this. And if we erase this circle, come on, circle. You're supposed to be erasing. Anyway, it's giving me a hard time. If we now circle this one, How many valence electrons does it have? 2, 4, 6, 8. So they're sharing electrons in order to get 8 valence electrons. And of course, this diagram here, as we showed, and this diagram here, these are known as Lewis structures. So here's the Lewis structure for the molecule F2. There's the Lewis structure. And later on in another video, we're going to show you how to do Lewis structures for other molecules. Okay? So let's do a few more examples. Let's do, for example, water, which is H2O. So we've got the Lewis dot diagram for one hydrogen. And we've got the Lewis dot diagram for our oxygen. And the Lewis dot diagram for our other hydrogen. And whoop, we're going to put it together. This electron's going to go here, and they're going to be shared, right? We're going to share those electrons, and we're going to share these electrons here, like so, right? They're going to go and share those electrons, and our water molecule is going to look like this. So in a water molecule, it's actually capable of forming 2 single covalent bonds, or if we wanted to write it with lines instead, as such. Now, one thing we failed to mention with the F2 is that the Lewis structure that you see shows the electrons that are involved in bonding. Alright, so those are the electrons being shared. So it shows the bonding electrons. And it shows the, and I'll draw it over here so you can see it better, the 2 non-bonding or lone pairs that are on the central atom that are not involved in bonding. So it shows the bonding electrons and the non-bonding or lone pair electrons. Okay. Let's do another example. Let's do like oxygen. O2. Okay. So O. There's one O. There's the other O. Now we have to put it all together, and we're all going to try to get 8 valence electrons around everything, except for hydrogen, of course, which hydrogen can't have 8 valence electrons. So let me go back to that water molecule for a moment. I apologize for not mentioning this back then. Go back to that water molecule. You see that the oxygen has its 8 valence electrons, which is the best that it can do, and each hydrogen has 2 valence electrons. Because, you know, getting 8 valence electrons is having that noble gas electron configuration for most elements on the representative elements, either on the left side or the right side. But for hydrogen, hydrogen's kind of like a helium wannabe, so the best it can be is like helium. So let's go back to our O2. Sorry about that. There's our 2 O's, and we're going to put those together. And we've got electrons here and here and here and here. We have to share electrons. So we're going to end up actually sharing 2 pairs of electrons. And when we share 2 pairs of electrons, what we have is a double covalent bond. Because 2 pairs of electrons are being shared by the same 2 atoms. And then, of course, we have the non-bonding or lone pairs that are sitting on the oxygen. So we've got 2 bonding pairs, and we have 2, 4, 6. We have 1, 2, 3, 4, 5, 6. We have 3 lone pairs on this oxygen and 3 lone pairs on that oxygen here. Then we have the 2 electron pairs being shared for a double bond. Okay, last but not least, let's do nitrogen, N2. Nitrogen looks like this, right? And nitrogen has 5 valence electrons, but it's going to need 3 more to get 8 valence electrons to be that noble gas configuration. And so what it's going to do is it's going to produce a triple bond. There's a triple bond. Or if we wanted to do it with lines instead, it would look like this. So what we now have is a triple covalent bond. And that's as far as you can go, a triple. Sounds like a hamburger menu at Wendy's. You get a single, double, or triple. Well, there's a triple bond, right? So we've got 1, 2, 3 pairs of electrons being shared, and the nitrogen here has 1 lone pair, and this nitrogen has 1 lone pair. And again, the 3 lines represent the 2 dots, right? So the lines represent a pair of dots. So we have 3 lines that represents 3 pairs of dots. There's our triple bond. There's our Lewis structure for nitrogen. Okay. If you have any questions, you can see myself or Mr. Walsh. Hope you enjoyed this video, and I hope it makes you feel good, because remember, it's all about the sharing. All right, you guys take care. Have a nice day.